Hi everybody, welcome back to the TETRIX RoboBench video series. This is Tim from Pittsco Education. And today's RoboBench, we're going to do a step-by-step build of the TETRIX MAX Ranger Bot. Sometimes we call it RangerMAX just for short. But we know that everybody learns a little bit differently. Some people like working from printed instructions. Some people like watching a video. So that's what we're going to do today. This is the build that we're going to do. This is the TETRIX MAX Ranger Bot or RangerMAX. We're going to build this bot from start to finish, so you're actually going to be able to follow along. We're going to follow the steps that we do in the build guide, and everything is going to be clear for you to see in a video format digitally. So let's go ahead. Let me gather everything up that I need, and we'll go through it step by step. This is all material that comes with your base set, except for my mat. And I'm going to go include that as part of my tools because sometimes it's nice to have a surface to work off of that if I drop something, it's not going to bounce and disappear off of a hard surface. And it keeps things from rolling around. So I'm going to include my mat as part of that. But I've got my 4 pieces of channel. I've got my tools that I need, a hex ball driver, my hex keys, my wrenches, and I have my socket head cap screws and my cap nuts. Now we're going to do this build in steps. So this first step is actually going to be the base. And this is the way that you would do this from the printed guide. But we're going to do the base first. Once we get that together, we're going to go ahead and then do the mounting deck, and then finally we'll add the wheels, and then finally we'll do the control systems, and then we'll test and actually demonstrate how everything is going to work together. But we're starting now with just the base. So let's start with our channel. Now this is regular TETRIX MAX C channel, and like any other C channel, it's got 3 sides. Now, the reason I'm going into this is that typically when you build with channel, one of the first considerations is load. And you usually always put the open end of the channel where it's going to be opposite the load, so that because that's the strongest direction that you can use for the channel. But the other consideration for us, especially for this build, is accessibility. So for us, because the robot's not going to weigh a lot, there's not a lot of load that we need to worry about. So we're going to be more concerned with accessibility. So I am actually going to turn my channel and orient it the way that I need to. And we're going to actually create basically a square base because that's one of the easiest types of structure to make. And the other consideration for us with this build, again, is we want this as your first build be fairly easy to do. So we want it to be easy, quick, and actually accessible for your first time builders. So I'm going to start with my channels facing out like this. I'm going to take my end channels. I'm going to move them over the outside like that, about 4 holes in. And again, we want the hole pattern to line up in the same way with this one on this side. About 4 holes in is where we want it to be. Now, I've got socket head cap screws and I've got cap nuts. And let's talk about those just for a minute because there are important fasteners. Now, the cap nut, I'm going to start with that because that's kind of the key to this. It's got a star-shaped washer on one side. And the way that these are meant to be used is that star-shaped washer needs to go against the surface you're tightening down again. And the idea is that as I tighten that down, that star-shaped washer is going to get compressed. It's going to bite into the metal, and it's going to keep you from needing to put a wrench on it. You still have a wrench to use, but it's going to keep that from hopefully being a necessary part of it. So it's self-tightening. So again, you've got the cap nuts and these socketed cap screws. Now, these are the shortest cap screws that we have. And this is about economy of resources. As you put multiple layers together with these, obviously the short screws are only going to go through a certain amount of layers. And then if you get multiple layers or thicker dimensions that you need to fasten through, you need to use the longer screws. So there are cases where the short screws won't work. So you want to use those where you can initially up front. So let's go ahead and start. I'm going to put 2 in each side. I'm going to go ahead and put that in just like that. Start with, again, one side. I'm going to take my ball driver, and you see I'm actually putting it through the channel. This makes it a little bit easier, and I'm taking my actually cap nut, and I'm going to put it on the end of my finger, and I'm going to put it right down underneath here. I can feel where that is, and I'm going to slowly tighten that up. Now, that's one way to do it, and that's what I'm comfortable with. But another way that you can do that is that you can actually take one of your wrenches. You can use it as a holding mechanism for your cap nut, so that it actually holds it in place. And you can use that instead of your finger. And I actually moved my screw out of place there. Let's go ahead and put that back in. Now, you don't want to tighten these real tight initially. This is about putting our structure together kind of in a temporary format so that we get fit of everywhere. And then once we get it fit, we'll go back and then we'll tighten everything up. And I'm going to repeat that on all four corners here. As you can see, this is where accessibility becomes important. If I had these channels turned in a different direction, I might have a little harder time actually putting screws in, accessing from the outside, but you can see because I have that channel face to the outside, it's fairly easy for me to stick my finger in from the side. Because of tolerance in the holes that the screw has to go through, there is a certain amount of play, and you can see that I just actually warped that into a non-square position because of the play in the hole that the screw has to go through. There has to be there so that you can actually get the screw through easily, but you need to be aware of that. So you don't want to tighten everything down until you actually make sure it's everything is fitting the way it wants to, the holes that you need it to be. But you can actually kind of line up the edges of the channel and to get it in a kind of a square position. Now, you could actually use a physical square to actually do that if you really want. It was really important for you to actually get it as square as you can, and sometimes it is. But for us, we can actually just line up those edges and then go back and tighten everything up. We're ready for step two. We've got our base together and we've got our material gathered up for our mounting deck. This is the surface that we're going to put things on, the battery and stuff like that. So I've got 2 of my flat building plates. I've got a couple of my L brackets, the switch mounting plate, the switch itself, 4 of my 32 millimeter standoffs, 4 of the 1/2 inch socket head cap screws, 16 of my 5/16 socket head cap screws, and 16 of my cap nuts. So I get everything together. Now, one of the things I want to make sure everybody is really comfortable with is the fact that it's important you get comfortable with the fact of realigning things. This is meant to be moved around so you can get it to where it's comfortable for you to actually work with it. So that's the first thing I'm going to do. I'm going to line this, change my orientation here, and I'm going to put my L brackets in place so I can mount my switch plate. So I'm going to start with one of my L brackets, and I'm going to start over here on the side. I'm going to hold this up so you can actually see it. So I'm going to take one of my short 5/16 socketed cap screws, and I'm going to start it through from the front side. So I'm going to line this on this second hole in from actually the third hole from my channel. If I count this as a half hole, 1, 2, third one in. And again, I'm just going to put that through, hold that in place, take my cap nut and put that over my nut from the back side and my ball driver, and again, just simply snug that in place. Not real tight yet, don't need to do that. Take another cap nut, hold it over the hole, and then my second socket head cap screw, the shorter one. Again, this is about economy of resources. I'm only going to go through 2 layers so I can use the short one. Now, one of the things that as you begin to build, not only with TETRIX, but other building systems, but it becomes obvious that things sometimes tend to be symmetrical. So typically, if I've stepped in this far from this side, I'm going to do the same thing from this side as well. So I get that symmetrical look and feel. It doesn't always have to be that way, but typically it tends to work out that way just because of the natural way that we look at things. And then That's also sometimes aesthetically a little bit more pleasing to the eye. But you sometimes can intuitively guess where things are going to go just based on the fact that typically things tend to be symmetrical. So I'm going to go ahead and put the last one in here. I'm only using 2 of these on each one because typically there's not a load, a lot of stress on this. So 2 is plenty. You don't need to put a lot of screws or nuts in a place where they're not really needed because of load. So I've got my L brackets in place. I can now go ahead and mount my switch plate. This is where, again, if we've got a little more thickness, we might go ahead and use the longer socket head cap screws. And I'm going to start from one side. And again, accessibility, just go ahead and tighten that down like that. And 2 on each side is plenty. Now, one more just kind of brief tip where you don't always have to do that, but there's 4 possible mounting holes on this L bracket and switch plate in a cross pattern. Just to show you, I've got 4 possible holes. Now, again, sometimes for accessibility, I'm going to turn this around so you can see this. I used the horizontal holes on my L bracket, which leaves me more room if I use the vertical holes on my switch plate. So again, that's just a tip. I could use the alternate holes, but it just gives me a little bit more room. And again, it's all about making this convenient and easy to do rather than difficult to do. Okay, I've got all of my socket head cap screws, cap nuts in place. Everything is aligned the way I want it to. I can go back and actually now tighten those up. Again, these are not load bearing per se, so they don't have to be super tight. You just want to make sure that as you snug these up, that vibration, you make them tight enough so that the cap nut actually holds it in place as the robot would roll across perhaps an uneven floor, create vibration. You don't want it to vibrate loose. So I have those mounted. Now I'm ready to actually mount my switch. Now, it doesn't matter in which orientation you point this, whether on is to the right or left. That doesn't matter. It's going to break the switch either way. But you want to just go ahead and place that in place, right like that. Use your hands to support the plate as you actually just press that down, snap it in place. The reason I say use my fingers, if I just pushed in the middle of that plate and I pressed a little bit too hard, there is potential, in fact, just actually snapping that plate. This is injection molded, so it's not a big risk, but it's something just to keep in mind. So I have my plate mount, my switch mounted. I'm going to go ahead and set that to the side just for a minute. And let's work on my my mounting deck plates. Again, I'm going to actually put a couple of standoffs in as a start. The easy way to do that is, again, I'll put my socket head cap screw, my short one, through, hold it with my finger. I can start that in place just like that and add my second one. Then I can snug those down. I can actually use my Allen key, hex key, and the smaller of the 2 wrenches. That'll go over the standoffs just like that. Hold that in place, and then I can snug those up. And we're, again, symmetrical, so we're going to do the same thing. We're going to create a mirror, in this case, on the other side. Okay. Now, again, you remember I talked about feeling comfortable moving these around, so that's what I'm going to do with my frame. We've been working from the top side, but I'm going to actually flip this over so that I can work from the bottom side, just because that's going to make it a little bit easier to work with. I want to put these plates just like this. They should span the length of the 2 channels supporting. I'm going to move them out so that they're just missing the switch plate on this side and have equal distance between the middle. So that should be about like that on both sides. And then again, I'm going to use 4 of my short socket head cap screws on each end, 2 in each one. I'm just going to put those in place so they kind of typically locates my plates. Now I can go back with my kept nuts and put those in place. Again, I don't have to get them tight, super tight this first time around. I just want to make sure that I get everything located and it fits the way I want to. And then once I do that, then I can go back and make sure everything is snug. Now, the important thing in that is that you do need to remember to go back and tighten everything up. It's awful easy as you go through this to put everything in place and then get in a hurry to move on to the next step and not go back and tighten everything up. So, okay, I have my mounting deck in place. You can see that I'm looking at it from the top side. It's going to look like this. I'm going to leave it upside down because now I'm ready to move on to my next step, which is adding my wheels. Got 2 of my 4-inch wheels, 2 of my Omni wheel assemblies. Now, if you haven't already put these together, please reference page 21 and 22 in your setup tips in the front of your builder's guide, and that will make sure that you have those put together and ready to go. But I have 2 of those. I have 2 of my Tornado motors, 2 axles. I've got 4 of my bronze bushings, 2 of my 32 millimeter channels, my motor mounts, and then I have axle hubs and motor shaft hubs. And I'll point out the difference between those as we actually put them on the robot. Some nylon spacers, my 1/2-inch socket cap screws, and my 5/16 socket cap screws, as well as my cap nuts. So I've got everything ready. Let's go ahead and start putting them on. I'm going to start with my 32 millimeter channels. We need to make mounting points for my Omni wheel assembly. So I'm going to start and I'm going to put those on the side that's closest to me. I'm going to use my 5/16 socket head cap screws, and I'm going to go ahead and just put a couple of those in each one of these channels. Like I have in the past, I'm going to make sure that I just get everything positioned before I actually then tighten everything down. And this is going to be a little bit more important than it has been in the past because it's going to affect our wheel alignment and whether or not our wheels are lined up properly with the chassis. So this is going to be kind of important as we get these in position, that we check the alignment of the 32 millimeter channel with our longer 288 millimeter channel. Now it's pretty simple. I'm just going to use the edge of my channel and the edge of my 32 millimeter channel to make sure those are aligned and are not at an angle to each other. Now I'm ready to go ahead and put bushings in each side. This is what the axles will actually ride on. We don't want steel on aluminum. We want the steel to be rotating within the oil impregnated bronze bushing. Acts as, again, a bearing surface these steel axles will go on. These are 4.7 millimeter D shaft steel axles, 100 millimeters long. We're going to just slide one in like that on both sides. And I want to show you the difference between an axle hub and a motor shaft hub. Now, because they look very close or very similar, and unless you hold them very close to each other, the difference would be the inner diameter of the hole in the center of the hub. One is for 4.7 axles. The other is 6 millimeter for the actual motors. So those are the difference between the two. You can use the axles only on the axle hub. So that's the easy one. What you have to be careful of is the motor shaft hub is actually big enough to go on either the motor or the axle, but it won't fit properly on the axle. So you need to only use this with the motor. So that's the important thing. I'm going to start. I'm going to put the axle just like a set hub on the inside. I'm going to take my hex key that fits my set collar. Make sure that it is on the flat side of the D shaft and just snug that down on both sides. Now I'm going to go ahead and use a spacer, nylon spacer on the outside on each side. This is to make sure that my Omni wheel assembly, when I actually put it on, does not rub against the edge of my channel. Now I'm ready to actually put my assembly in place. Again, making sure that the bushings don't fall out of the Omni wheel assembly. You'll see that that spacer will keep my distance from these rollers from the edge of this channel. I'm going to space that out just enough so that I can put another nylon bushing on the outside. And last but not least, follow up with another axle hub on the outside. Then I'm just going to adjust my length so that it's kind of just barely sticking through on both sides, and tighten this set screw down. Now, we also could have used actual set collars for these two positions, but we're using the axle hubs just because they're a little bit larger. Again, we mentioned in the beginning of this build, we want this first build to be easy for people to do, so we're actually using the larger components with the larger wrench just to make that a little bit easier for you this first time through. And then I want to spin that after I've got it in there to make sure that it is lining and rolling true with my chassis. I'm ready to do that now on the other side. This nylon bushing on the outside is going to, again, keep the button head cap screws that are part of this Omni wheel from rubbing against this axle hub. Again, these just need to be on there. You don't want to squeeze these together and create friction. They're just there to keep the Omni wheels from moving laterally on the axle and coming off the axle. We'll spin to make sure they're moving freely and lined up. And then I'm going to go ahead and go back and snug those up good. It's important that you're on the flat side of the axle. You can tighten these down on the rounds, but if you do, they're liable to slip and what we call score the axle or gall the axle. That's not a good thing, because if that happens, then you can't get the axle hub back off to use it again. So it's important to make sure that it's on the flat. Okay, we have our Omni wheels mounted. Now we're ready to move to our motors. We have to start with our motor mounts. These are a split motor mount. You can see that one side is solid, one side is split. So we will mount this side solid tight first, and then position our motor in place, and then actually tighten this side down to clamp the motor in place, hold it securely. So I'm going to go ahead and start and put it on the opposite end. I have longer 1.5" socket head screws that are going to be used. Just like that. And I'm going to do the same thing on my opposite side. Take my cap nuts. These are the same cap nuts that we use for the rest of everything else. And actually put those at the bottom. Okay, again, I'm going to check my alignment of a mount with the channel. I want to make sure that it's parallel to the edge of my channel. And you can see there's, because again of the tolerance between the hole and the socketed cap screw, there is some play there, so you want to make sure that they are in alignment. Snug that down a little bit more. Now I'm ready to go ahead and put on my motor. These motors, I want to make sure that we look at this, they do have what we call an offset output shaft. If you look at that from the end, you'll see that the output shaft is not in the middle of the motor like a planetary motor. This is a spur gear type of motor, so it is offset. Now, the advantage of that is that as I rotate that within my motor mount, and I'm just going to kind of turn that around like that, you'll see that the actual height of where that output shaft is can vary, which is important as we actually finish the build, and I'll show you how it can affect the attitude of the robot as it sits on a flat surface. So I'm going to start and just put that to one side, just like that. And I'm going to go ahead and just kind of start as a starting point with that kind of in the middle, facing up. I can do the same way with this one on this side. We want that clamp to be on the gearbox, not on the body of the motor. This is where the load would be on the motor, so we want to make sure we clamp on the gearbox. And now I can snug this down a little bit. I still don't want to make it really tight because I mean to rotate that, so I'm just going to snug it just a little bit so that the motor doesn't back out of my mount. And now I'm ready to actually mount my wheels. Now I'm going to again, first I'm going to mount my axle hub. onto the output shaft of my motor. Again, using my Allen key, making sure that it's on the flat. Once I have that on the flat of my output shaft, you can see that I can rotate the shaft of my motor by using my wrench. Now I'm ready to go ahead and mount my wheel. I'm going to mount my wheel just like this. It's going to center itself on the output, the motor shaft hub. I'm going to use my longer 1/2-inch socketed cap screws. And I'm going to turn this so that I can actually see it myself, and then I'll rotate it so you can see it. This is where the shorter screws will not reach, so you definitely have to use the 1/2-inch socket screws when you attach wheels because of the thickness of the wheel itself. And this is just like changing the tire on your car. When you snug these down, again, I'm going to snug that, and then I'll come back. You can see that I've got the 4 socketed cap screws tightening that down. And then when I rotate my wheel, it's rotating again, not in a wobble, rotating in line. I can do the same thing now on this other side. Rotate that to make sure it's not wobbly, and we're good there. Now I'm going to check my height. And again, I'm going to set this just like that. And you can see that because I've rotated that output shaft to the top of, or actually to the bottom of the position, it actually has elevated this end of my robot. That would work, but it could cause potential problems. So we want to kind of level it out, and I can do that by rotating that motor in the mount. So I'm going to loosen over my split end, and I'm actually going to rotate that more toward the center. Now, when I set this back down, you can see that should have made a difference in the orientation or the attitude of the plate. And if it's not quite right the way you want it to, you can make another adjustment. And actually, if you need to, actually sometimes even get a level, depending on how important this is for you, to put that on top and actually keep tweaking that until you get it actually level. We're going to go ahead and I'll leave that for now and move on to the next step. Okay, we're at step number 4, where we're ready to add the control system and get this all thing buttoned up and ready to go ahead and operate. So I've got some things here. I've got my TETRIX RC motor controller. I've got the cables that come with that to be able to attach a control system on up. I have the cable for my on-off switch, 32mm standoffs, my battery clips, my battery, socketed cap screws, kept nuts, and my controller off here to the side. So let me start with my 32mm standoffs. I'm going to go ahead and, like we did earlier, start here in the middle. Okay, those are nice and snug. I'm going to go move on to my battery clips. These are going to hold my battery in place and keep it from moving around on my robot once I get in place, but still make it easy to replace or charge when I need to. Okay, battery clips are in place. Now is a good time to mount our receiver for our transmitter. Let's put it right over here to the... Again, this is in a plastic case, so we don't have to get really tight with that. We just need to make sure that it's not going anywhere, but still accessible so that when we plug our cables in, we don't have trouble accessing those. Last but not least, we need to mount our controller. Now, we could mount this in different places, but the consideration that we want to always be aware of is there are cables that have to reach from different components. So even though I have this here, if I turn this around in this direction, so my connection was a little bit further away from my switch, it probably would not reach. So you need to keep that in mind, is that what's the length of my cables and how far is that away from the different components. So I'm going to turn that around so that it's facing in this direction. My cable connection is going to be closer to my switch, and I can go ahead and use that to tighten this down. The same way with these 32mm standoffs, I'm basically just creating support at this end of the box. I probably could move this box on the channel and reposition a little bit and have enough control or enough support but this just allows it to be a little bit more supported on both ends. And all of my components are firmly mounted. I'm going to just test fit my battery. It's going to fit right in there. So now I'm ready to go ahead and wire everything up, make sure all my connections are made and get that done. And this is important to actually finish everything off. So I'm going to take my battery out just temporarily. I'm going to turn this over just like this. And I'm going to start with my on-off cable. I've got two sides. Now I'm going to hold this up like this so you can kind of see it. And basically what we're going to make sure that we do is we're going to put the switch in the middle of my red wires. So when I open and close that switch, it's going to open or close a circuit. So the two blue connectors on the red wires will go onto our switch. It doesn't matter which side goes into which, but you want to support the switch with one hand and then go ahead and push those blue spade connectors onto the switch spades, just like so that we have a firm connection. And those are rather tight, so you need to make sure that they're pressed down in firmly in the middle. I'm going to push my wires up through the middle here, turn this back over, and here's where you're going to see that there is not a lot of room to make this actual connection. So carefully, I'm going to move my wires and make that connection just like that. And again, that's fairly snug. If I had that switch oriented any other way, turn my box around, that switch cable would not work. Doesn't mean you couldn't get a wire extension and make it longer, put it wherever you need to, but for this build, to keep from using a wire extension, you need to make sure those are in close proximity. So now we need to go ahead and do our motors. So I'm going to, again, turn this upside down so you can see. Undo my little wire ties here. Now, I'm not going to throw these wire ties away because sometimes they find a use in actually organizing our cable. So I'm just going to set those to the side. And same way with this one. And typically, the first thing I do is we are not going to use the encoder cable. So I've got a power cable that goes through my motor, and I have an encoder cable. Because I'm not going to use these encoder cables, I'm going to go ahead and remove them so that they don't get in the way. Eliminate some of the wires. Now I'm going to go ahead and put my wires through the middle here, and so that I can connect them to my box. Keeping track which side is which, because again, that's going to play a part in how my robot is controlled. I'm going to turn that over. Now, typically you can do this in different ways, but what I like to do is kind of associate a side with a motor port. So in this case, my left side, I'm going to put it into motor port 1. And again, we want red to red, black to black. These cables will snap together like that, so you can go ahead and do that, and then this will fit right down like that on that side, or you could leave them loose. It's up to you. You leave them loose, you just have to make two separate connections just like that. Again, though, the main thing is match up your colors, red to red, black to black. Now, you can begin to see that I'm getting some cable clutter with the way things are going together. So we need to make sure that we take care of that, but I'm going to go ahead and put my battery in there. This is going to connect to my on-off switch, just like so. I can test to see if I have power by flipping my switch, and I'll get a blue power indicator light. Shows that I have a circuit, everything is powered on. Turn that back off just for a minute. I need to make my connections between my receiver and my controller. That's where these two 3-pin input channel connector wires come in play. There are 2 channel inputs. I'm going to turn this around so that you can see that. On the top of my box, I have input 1, input 2. And there also is a wiring diagram as far as the black, red, and white wire. Black is negative, Red is positive, white is the signal wire. So in this case, we want to make sure that the black lines up with the negative on our diagram, which would be toward the inside of the box. I'm going to take input number 2 from the controller, and I'm going to, for this particular configuration, again, this can change depending on how that you want to physically drive your robot, but I'm going to put that into channel number 2 on my receiver. Again, paying attention to signal wire, positive and negative. In this case, on the receiver, black or the negative is going to be to the outside. Plug that in, and then the final wire is going to go from input number 1, matching that up, into the channel, because we're going to do a single stick, channel number 4 on my receiver. And again, these instructions and which channels go where, including a nice little diagram, are part of the builder's book that is available for download from the website, as well as in your kit coming physically. So now I have everything gone ahead and plugged in. I want to show you the difference between what this looks like as far as cable clutter and one that's already been organized. So I've got 2 identical robots here. One that we prepared ahead of time and the one that we just finished building. And I want you to look at the difference between the cabling. Again, we've got extra cable that's kind of in the way. Here it's organized. If you look at the back, you can see the difference in the cable clutter. The main thing you want to really worry about is the fact that we don't want wires to get hung up, snagged, or into moving parts. That's important, as well as for maintenance of the robot, but also organization and just making sure troubleshooting. It's just a really good idea to go ahead and clean up the wiring so that it's easy to maintain and it doesn't get in the way of functioning. You can do that with cable ties. That's what I've used on this robot, or you can go back to the wire ties that come with your motors and actually use those to help organize those cables. So again, not a have-to step, but it's a good idea just as far as general practice to get in a habit of going ahead and doing that last little bit to keep your robot actually functioning properly. Okay, we've got everything together. We've done our cable management. We've got everything organized up out of the way. Nothing's in the potentially in the hazard zone of moving parts. We're ready to go ahead and actually see this robot work. So let's go ahead and walk through it. We're going to go ahead and power on. We should see a blue light on our control box and a flashing yellow light if we're in the mixed mode. We should also see a red flashing light on our wireless receiver. And as soon as we power on our controller, which will get a green light here, if they are paired, which they should be from the set, you will see then a solid red light. Show this so you can see it in our wireless receiver. This indicates that we have a paired set. And you'll notice that our flashing yellow light is no longer flashing. We are ready to drive. Now, this is set up initially on a single stick. My left side, because I'm using my number 2 channel, which is my y-axis on my left side to actually move forward or backwards. And you can see that I'm actually going backwards from what I just said. Now, we can fix that by switching our dip switch on our receiver. So we can actually change that motion. There's 4 little switches that allow you to change the direction of input. So I'm going to go to number 2. I'm going to switch that. I am going to, you hear the motion, that little whine that you heard was the trim. So now when I push my joystick forward, my robot will go forward. And I pull it back and my robot goes to the back. If I move it to the side, it turns left. If I move it the other direction, it turns right. So now I have a fully functioning robot that I can remote control drive around. Now, what happens if your robot is not paired or your receiver is not paired to, transmitter is not paired to the receiver? That's easy to fix, not a big deal. We go ahead and we're going to start by powering off our gamepad. We'll go to our receiver, and again, we'll know that it's not paired because when I turn my gamepad on, my light stays flashing. So the way to fix that is take something small, and there's a small reset button on the side of this receiver. And when I press and hold that in momentarily, you'll feel it indent. The light will turn solid and I release it. Now I have a rapidly flashing red light. All I need to do is power on my gamepad. As soon as I get my green light, there is a connect button that I can press. I hear a tone, hear another tone, and now I should have a solid red light and I'm back to a paired condition. That's all it takes to go ahead and pair a new controller with an old receiver or the other way around. So I'm good to go and I'm ready to drive this thing and ready to go on to do our first activity. So like we always say, have fun, build some robots, come back and see us.